Good day everyone! Welcome for today's another video. I am Evan from group number 1 and we will be going to discuss experiment number 9 entitled Sieving and Plastic Limit by Atterberg's Method. The Swedish soil scientist Albert Atterberg originally defined 7 limits of consistency to classify fine-grained soils. But in current engineering practice, only 2 of the limits, the liquid and plastic limits, are commonly used. Plastic limit is defined as the water content in percent of a soil at the boundary between the plastic and semi-solid states. For today's experiment video, our objective is to determine the plastic limits of fine-grained soil using the Atterberg method. For the scope of the experiment is to follow and perform only the soil that passes through the number 40 sieve. Therefore, the relative contribution of this portion of the soil to the properties of the sample as a whole must be considered when using this test to evaluate properties of a soil. The experiment followed the standard test method for liquid limit, plastic limit, and plasticity index of soils, which is the ASTM-D 4318.
Now, let's go to the materials and apparatuses. The materials and apparatuses used for this experiment are the following: soil specimen, weighing balance, table, moisture cans, spoon, spatula, distilled water, and a 3 mm diameter rod. Methodology. Step 1. 3 empty moisture cans with their lids were weighed. The respective weights and can number were recorded. Soil samples and distilled water were mixed until the soil is at a consistency that can be rolled without sticking to the hands. Step 3. Form the soil into an ellipsoidal mass. Roll the mass between the palm or the fingers and the glass plate. Sufficient pressure to roll the mass was applied into a thread with uniform diameter by using about 90 strokes per minute. The thread should be formed so that its diameter reaches 3.2 mm, 1/8 of an inch, taking no more than 2 minutes. Step 4. When the diameter of the thread reaches the correct diameter, break the thread into several pieces. Knead and reform the pieces into ellipsoidal masses and re-roll them. Continue this alternating roll, gathering together, kneading and re-rolling until the thread crumbles under pressure required for rolling and can no longer be rolled into a 3.2 mm diameter thread. Step number 5. The portions of the crumbled thread were gathered together and placed into a moisture can, then covered. If the can does not contain at least 6 grams of soil, add soil to the can from the next trial. Immediately weigh the moisture can containing the soil, record its mass, remove the lid, and place the can into the oven. Leave the moisture in the oven for at least 16 hours. Step number 6. Steps 3, 4, and 5 were repeated 2 times. The water content from each trial can be determined by using the same method used in the previous steps. Remember to use the same balance for all weighing.
In this given section, this illustrates the table sheet or the data sheet that was used throughout the methodological experimentation, in which these values are interconnected with each other to attain the values of water content and the plastic limit of the soil sample. The formula below is used to attain the values of the water content of the soil, in which it is achieved by dividing the mass of the water from the mass of the oven dry soil sample. Also, always remember to use kilograms. From the conducted experiment, the 3 samples resulted in 18.75%, 14.679%, and 16.495% water content respectively. The average water content of the 3 replicates is 16.641%. This indicates that at 16.641% water content, the soil changes from a plastic to a semi-solid state. However, Since there is no data available for the liquid limit of the samples, the plasticity index cannot be computed, and thus, it cannot be determined whether the sample is non-plastic, slightly plastic, medium plastic, or highly plastic.
The water content obtained from the three samples were the following: 18.75%, 14.679%, and 16.495% respectively. Based on the data, the average water content is 16.641%. This value represents the percentage when the soil changes from a plastic to a semi-solid state. However, since there is no data available for the liquid limit, the plasticity index was not determined. In conclusion, the experiment's objective, which is to determine the plastic limit of soil using the Atterberg method, was conducted successfully.